All right, problem 9, it says that we're going to choose an American adult at random, and the probability that you choose a woman is 0.52. So let's start off by writing the probability of W is 0.52. Then this is the probability that the person you choose is never married is 0.25. So let's then write the probability of N for never marrying is equal to 0.25. And the probability to choose a woman who has never married is 0.11. So the probability of W and N, WNN is 0.11. And so the probability that the person you choose is either a woman or has never married is therefore, so we want to find the probability of W or N. W or N. What is that equal to? So for this problem, I recommend making a two-way table. So let's make it basically a two-way table, just like what the title says. And across the top row, we're going to have, then we're going to have the choice of, being a woman, or we say just not being a woman, what W complement. And then the other on the side will say being married, or probability of never being married, or N complement. Again, we don't care about the details of what the other possibilities are. We just care about it being not never married, which is kind of confusing. That's why I just like go with N complement. And then we go ahead and we know that everything has to add up to 100% or 1.0, and we fill in what we got. So we know the probability of W of being a woman is 0.52. And so that will go here because that's this and this. The probability of N is 0.25. That'll go here. The probability of W and N is 0.11, which will be right here. And then we can fill in the rest because now we know 0.11 plus 0.41 is 0.52. 0.52 plus 0.48 is 1. 0.25 plus 0.75 is 1. Then here, it'll be 0.34 because 0.34 plus 0.41 is 0.75. And right up in here is 0.14. Now we just look to see what we want to find. The probability of W or N will be this. This is W, that's W. It'll be these three. Because these three qualify as W or N. Just don't double add any of them. So this will be equal to 0.11 plus 0.14 plus 0.41, which will then just be 0.66. The answer is B. A deck of playing cards has 52 cards, of which 12 are face cards. You shuffle a deck well and turn over the top 3 cards one after the other. What's the probability that all 3 are face cards? Okay, so for this, we're going to use the probability multiplication rule, where you just multiply, one event by the others. So out of 52 cards, 12 are face cards. So the probability of getting a face card on the first draw is 12 out of 52. So then we're going to multiply this by the probability of getting a face card on the second draw, given that you got a face card on the first draw. So since you got a face card on the first draw, there's only 11 face cards left. And since you drew a card, there's only 51 cards left. So you're going to multiply that by 11 over 51. And then on a third draw, you only got 10 face cards left because you already drew 2 of them. And then you only got 50 cards left because you already drew 2 out of the 52. So you multiply those 3 fractions by one another, and we will get a fantastic number. It'll be 0.0099. It's interesting. Let's see. Okay, yeah. So this is basically really close to 0.01. That makes sense. And so the answer is C. All right. Nice. I'm done with the multiple choice section of the practice test. So feel free to take a break and let me know if you have any questions and any feedback in the comments section. And of course, subscribe if you haven't already. And I'll see you guys in the next video.